So in this video we're going to look at the halogens. The halogens is a group on the periodic table. It's group 7 on the periodic table. So here's the periodic table here, we've got group 7. The halogen group is this group: fluorine, chlorine, bromine, iodine and astatine. This group they all have 7 electrons in their outer shell, and they are essentially famous for being very, very reactive non-metals. So they're a bit like the alkali metals, group 1, this one here: lithium, sodium, potassium, iridium, cesium and francium. These are very reactive metals. This is just the same, but non-metals. These are reactive non-metals, group 7, the halogens. So, there's quite a lot of information we need to know about halogens, and so we can quickly fill this in. In what group of the periodic table are halogens? Answer, group 7. One of the things we need to know is a test for chlorine. Chlorine is the second one down. It has a very characteristic test. If we have damp litmus paper and subject it to chlorine, the chlorine will dissolve in the dampness on the paper, and litmus paper is red in acid, the damp chlorine will be acidic. So damp litmus paper turns red, and then bleaches. Because chlorine is a bleach as well, so bleaches means it turns white. So now we have a table about halogens we just quickly need to fill in. So we've got the members of the halogen here in order of atomic number. So in other words, as we go down the group. So it's going to be fluorine, chlorine, bromine, iodine and astatine. Okay, you can write all those ones in at your leisure. Fluorine, chlorine, bromine, iodine, astatine. Okay, the colour. We need to know the colours of each of these. So we've got a very pale yellow for fluorine, chlorine, green, again pale green, bromine, brown, iodine solid is grey. Interestingly with iodine, the vapour is purple, so maybe we'll just put an asterisk there, and should we do that over, we'll do that over here, the asterisk. So iodine vapour is purple. Also, we have iodine solution, iodine aqueous solution. Oh dear, that one is going to be brown. Okay, but the iodine solid is grey. As we go down this group, the colour intensity, hopefully you can see, is getting darker. So iodine, astatine, black. And that's the trend. So the colour intensity trend, as we go down the group, it gets darker. The physical state, this means is a solid, liquid or a gas. Well, this one's fluorine is a gas, chlorine is a gas, bromine at room temperature, let's say physical state, let's put that in there actually, it's room temperature, about 20 degrees, is a liquid. Iodine, solid at room temperature, and same with astatine. So hopefully you can see as well, as we go down here, the boiling points, the melting points continue to get higher as we go down the group. So again, we have a trend. As we go down the group, the melting point gets higher. Reactivity trend. The most reactive halogen of all is fluorine, then chlorine, then bromine, then iodine, then astatine. So as we go up this group, okay, they get more reactive. As we go up, they get more reactive. So these are trends in this group that we need to know. Right, the halogens will react with metals to form ionic compounds, and it's not unusual to be asked word and symbol equations of these. So word equation first, sodium and chlorine. Sodium and chlorine, well, that makes a compound of sodium and chlorine only. So that will be sodium chloride, and ending "ide" means only. Right, so to do a symbol equation, absolutely essential we get the formulae right. Sodium is a metal, hangs around on its own. Chlorine is a diatomic gas when it's on its own, so we must have that little 2 after it, must have it. Formula of sodium chloride, you can't just make this up. Remember, you have to look at the periodic table to find out where these elements are. Sodium is in group 1, therefore it forms a 1 positive ion. Chlorine in group 7 forms a 1 negative ion. So that the formula of that compound, we have to look at the charges on these ions, and we have to ask ourselves, are these charges the same? Are they more positives? Are they more negatives? Well, in this case, they are the same. So because the charges on the ions are the same, you've got one positive and one negative, the formula of sodium chloride is simply NaCl. Okay, now we've got the formulae right, now we can balance it. One sodium there, two chlorines there, one chlorine there. So you need to put a big 2 before. Okay, that's how we balance. You can't put a little 2 after the chlorine, that would change the formulae. That's not allowed. Okay, in doing that we upset the sodiums. We've got 2 Nas, 2 sodiums, so we need 2 sodiums there. That equation is now balanced. Now magnesium with fluorine. So again, word equation, they are the reactants, magnesium plus fluorine. It's magnesium and fluorine only, so that's going to make magnesium fluoride. The ending "ide" means only. Simple equations, magnesium, that's a metal, so it's on its own. The fluorine is a halogen, so it's one of these diatomic gases. Diatomic means it's made of 2 atoms, that molecule. And the formula of magnesium fluoride. Again, we need to look at the periodic table to find the charges that the ions will form. Magnesium is in group 2, so it has 2 electrons in its outer shell. So when it forms a compound, it wants to lose those 2 electrons. So it ends up being magnesium 2+. Fluorine is a halogen, and like all halogens, it's group 7, so it only wants to gain 1 electron, so it becomes F-. Ask yourself the question, do we have more positives or more negatives, or are they the same? Here we've got 2 positives and 1 negative. We've got more positives. So to balance those out, we're going to need another negative. So now we've got 2 positives, and now we've got 1 negative, 2 negatives. So the formula of this compound, MgF1, F2, MgF2. And now, balancing, 1 magnesium, 2 fluorines, 2 fluorines. Just so happens that equation is balanced. Right. Carrying on, we've got a couple more here at the top of this page. I'm just going to go straight to the simple equations. Copper 2, chloride is formed. So it's copper reacting with chlorine to make copper 2 chloride. So that's going to be Cu is the copper plus chlorine makes copper 2 chloride. Well, that's Cu2+. Cu2+. We know it's 2+ because it's got a Cu2 after it there. That 2 there, Roman numerals, means it's 2+. Cl- is the halogen. So again, do we have more positives or more negatives? We have more positives, so we need another negative. CuCl1, 2. So CuCl2. Again, that equation is balanced. Right, this is the examiner's absolutely favourite question. Can you please write a balanced simple equation for this one? So we've got iron reacting with chlorine to make iron 3 chloride. That iron 3 means it's Fe3+. Let's do it up here. Fe3+. It's reacting with chlorine, so that's going to be Cl-. Okay, we know it's 3+ because of the Roman numeral 3. We know it's Cl- because chlorine is in group 7. It's a halogen. Do we have more positives or more negatives? Answer, more positives. So we're going to need 3 chloride ions to get 3 negatives. 1, 2, 3. So the first thing we write down here is FeCl3. We've got Fe plus Cl2. Now balancing this equation. 1 iron, leave that for the time being. 2 chlorines, 3 chlorines. Okay, so this quick way to do this is say, what's the common multiple between 2 and 3? And the answer is 6. So I'm going to need 6 chlorines on this side and 6 chlorines on that side. Okay, so I could put a 3 there and a 2 there. That would work, make it work. That's the quickest way to do it. If that didn't make sense to you, just ask yourself the question, where are there more chlorines? Answer, here, on the right-hand side. There's 3 chlorines here, there's 2 chlorines here. So I need more chlorines here. Ask yourself the question, what number is there right now? You say, I can't see a number. Well, if you can't see a number, there's number 1. So what number comes after 1? Answer 2. Put a 2 there. If you put a 2 there, okay, let's do it up here quickly just to make a bit of space and so we can work this out. Fe, I said put a 2 there, didn't I? 2Cl2 makes FeCl3. Okay, ask yourself the question now, do I have more chlorines on this side or this side? 2 times 2 is 4 chlorines, and there's 3 chlorines over here. So I've now got more chlorines on this side, so I need more chlorines over here. Ask yourself the question, what number is there? What number's there? The answer is 1, so what number comes after 1? Let's say 2. Put a 2 there. Okay, now check again. How many chlorines on this side? 2 times 2 is 4. Now check again. 2 times 3 is 6. So which side do we have more on? We've got more on this side, so we need to increase the number here. What number do we have here? 2. What comes after 2? 3. put the 3 there. 3Cl2, 3 times 2 is 6, 2 times 3 is 6. We now get the chlorines balanced by just flick-flacking back across that arrow each side. The equation, however, still isn't balanced. We said 3 there and 2 there, didn't we? Because in doing that, putting that 2 there, we change the ions, the Fe, so we need 2 Fe there. Okay. The halogens react with metals. They also react with hydrogen. So we can quickly do word equations for those. Once we've done one, they're all the same. Hydrogen plus fluorine makes hydrogen fluoride. And that's going to be H2 because hydrogen is diatomic, plus F2 because fluorine is diatomic. Now both of these form one bond. Okay, so the formula is going to be HF. Whenever a halogen reacts with hydrogen, they always form one bond, and you can do the covalent bonding diagram to show that. To balance it out, 2 hydrogens there, 2 fluorines there, so we need a big 2 before that hydrogen fluoride. And it's the same for all of these. Hydrogen reacts with chlorine to make 2HCl. Okay. Not going to do this last bit here, that's year 10 revision. Okay, I just quickly want to finish off here now, because this is really important. Are these hydrogen halides that we just looked at here, okay, are they acidic or alkali when dissolved in water? Well, this halogen group is opposite to the alkali metals group. Okay, if you remember, the alkali metals group, very reactive metals there. When they dissolve in water, they make alkalis. Okay, this group, reactive non-metals, when they dissolve in water, they make acids. So hydrogen chloride, for example, when it dissolves in water, makes hydrochloric acid. They are all strong acids. These are the strongest acids that we know about. Hydrofluoric acid is so corrosive that it will dissolve, it will corrode glass. Okay, it's the most corrosive acid we know about, hydrofluoric acid. They're all acidic. Okay, acidic. And what we'll do a bit more halogens, a bit more about the halogens. We'll do a displacement reaction of halogens in the next video.